All right, let's jump into our last portion of chapter 1.2, where we talk about circles. The standard form of the equation of a circle is given by x minus h squared plus y minus k squared is equal to r squared, where the ordered pair h comma k represents the center of the circle and r is the radius of the circle. You'll notice in the image on the right, we've got the center in red, h comma k. Radius is the distance from the center to any point on that circle. This equation comes directly from the Pythagorean theorem and the distance formula. You might recall the Pythagorean theorem says that the sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. Well, how does that actually work out? Well, by definition, the distance from the center of a particular circle to any point xy on that circle must always be the same. That distance is called the radius. So if we go over to our circle and we plot the point x comma y, here we have it in green, just some ordered pair. Notice that we can generate a right triangle. The bottom of this right triangle, the length of the side of the bottom of the right triangle can be found by taking the difference of the x-coordinates of our 2 points. Notice that is x minus h. That's x2 minus x1. Similarly, we could find the right-hand side of the triangle by finding the difference between our y-coordinates. That's y minus k. Well, taking the square of x minus h, that's x minus h squared, plus y minus k squared, according to the Pythagorean theorem, would have to equal r squared. Again, the sum of the squares of the sides of a right triangle is equal to the square of the hypotenuse. In this case, the radius is the hypotenuse of this right triangle. Let's get to some examples. Write the standard form of the equation of a circle with a center at 2, negative 1 and a diameter of 8. Sketch its graph. Now, anytime you guys are doing a problem that involves some sort of formula or standard form of an equation, it's always helpful to write down that formula first. In this case, we know that the standard form of equation of a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. And in order to complete this equation, we must have 2 pieces of information. Those 2 pieces of information are the center and radius. Whenever you want to write an equation of a circle, you have to know where the center is, and you have to know the radius of that circle. The good news is that we have our center. The center is located at 2, negative 1. That is given information. Pretty straightforward. Radius, however, is a little bit trickier. We are given the diameter, which is the distance across the circle through the center. Well, as you guys already know, radius is equal to 1/2 of the diameter, which means that r must be equal to 4. Now that we have h and k and r, we can plug those into our equation to get our standard form. That leaves us with x minus 2 squared plus y minus a negative 1 squared is equal to 4 squared. Doing out a little bit of algebra, we can simplify things to make it look a little bit nicer. X minus 2 squared plus y plus 1 quantity squared. Notice that subtracting a negative becomes a positive, and squaring our radius of 4 leaves us with 16. To sketch a graph, the easiest thing to do is to plot the center and then plot points to the right, above, to the left, and below the center using the radius. We know that we have to go 4 units to the right of the center, 4 units above the center, 4 units to the left of the center, and 4 units down from the center. And then we can connect those dots, creating a circle. Let's try another one. Write the standard form of the equation of a circle with endpoints of diameter at 3, 4, and negative 5, 0. Sketch its graph. As we said, write out the standard form. Best thing to begin with. We know that in order to write an equation of a circle, we have to have 2 pieces of information, the center and the radius. Well, in this case, how can we find our center? If we have endpoints of diameter, that means that our center is going to be the midpoint of these 2 points. Imagine that. We're going to have to use something that we learned previously to help us out in a problem here. So to find the midpoint, recall that we are taking the average of the x-coordinates and the average of the y-coordinates. That's 3 plus a negative 5 over 2 for the average of my x's, and 4 plus 0 divided by 2 for the average of the y's. All right, so that leaves us with the center at negative 1, 2. Radius. Remember that radius is defined as the distance from the center to any point on the circle. So what we can use is the distance formula that we learned earlier on. Yes, we can take the distance from our center point at negative 1, 2 to either of the given endpoints of diameter. Now, it's up to you to choose which ones you want to use. They will both give us the exact same answer. So we have our radius, or distance, is equal to the square root of 3 plus 1 quantity squared plus 4 minus 2 quantity squared. Notice that I am using the center and the ordered pair 3, 4, right? So we have the difference of the x-coordinate squared. That's 3 minus a minus 1 squared, plus the difference of the y values squared. That's 4 minus 2 quantity squared. All right. Taking the square root of that will give us our radius. That's the distance formula. Feel free to go back and take a look at your notes. Hopefully you have that distance formula written down. Well, simplifying those down, 3 plus 1 is 4, squared is 16. 4 minus 2 gives me 2 squared, which is 4. I have the square root of 16 plus 4, which is root 20. Now, we certainly could simplify root 20 down if we were trying to find the radius, right? We know that 20 has factors that are perfect square. 4 times 5, right? That would be 2 root 5. However, in this case, notice that the problem only asks us to write the standard form of the equation of the circle. And what are we going to have to do with r? Yep, we're going to have to square it. All right, so not necessary to reduce that radical in this particular case. Now that we have r and we have our center, we can plug those into our equation. We have x plus 1 quantity squared plus y minus 2 quantity squared is equal to 20. Notice when I square that r value, squaring undoes the square root, and we're just left with 20. Again, to sketch the graph, start by plotting the center. And in this case, we are going to go root 20 units to the right, up, left, and down from the center to plot those points. We could also use the endpoints of diameter, as they're shown in this case, to help us out. All right, another one here. Write the standard form of the equation of a circle with a center at 3, negative 2, and a solution point negative 1, 1. Sketch its graph. Again, here's our standard form. Should be locked in your brain by now. Again, what are the two pieces of information we have to have? Well, we have to have the center and the radius. Well, we have the center, right? The center is given information, 3, negative 2. That is great. Now we just need to know what the radius is. A couple different ways to go about solving for the radius. One, we could use the distance formula to find the distance between the center and the solution point. So to do that, again, we have our distance formula. Distance in this case, we'll call the radius, is equal to the square root of 3 plus 1 quantity squared. That's the difference of the x-coordinates. That's x2 minus x1 squared plus y2 minus y1 squared. So we have plus negative 2 minus 1 quantity squared. We're finding the distance between those 2 points, the center and our solution point. x2 minus x1 squared plus y2 minus y1 quantity squared. We take the square root. 3 plus 1 gives us 4 squared is 16. Negative 2 minus 1 gives us a negative 3 squared is 9. We have the square root of 16 plus 9, which leaves us with the square root of 25, telling us that our radius is equal to 5. Again, once we have the center and once we have the radius, we can go ahead and plug those values into our standard form. we end up with x minus 3 squared plus y minus 2 squared, y plus 2 squared, that's subtracting a negative, becomes a positive, is equal to 25. To sketch the graph, we can plot our center and know that we are going to have to go 5 units right, 5 units up, 5 units left, and 5 units down from the center. All right, there you have it, chapter 1.2.